Today's lesson covers 4445, scatter plots, lines of fit, correlation, and causation. First thing to talk about is bivariate data. This is just data with two variables, the type of data you would use to create a scatter plot, comparing two quantities and looking at the relationship. So that scatter plot shows the relationship between a set of data with two variables, graphed as ordered pairs on a coordinate plane. Could be something, I always like to use the example of arm height or arm length and height, or it could be gallons of gas pumped and the cost of your bill after pumping the gas, and things like that. The other thing we'll talk about is correlation and association. The correlation is that relationship shown in a scatter plot. You can have different types of correlation. Positive correlation is going to look like a positive slope as you look at it from left to right. As your x value increases, your y value does. Also, such as the more gallons of gas I pump, the higher my bill is. Or the taller the person, generally speaking, the wider their arm span is. Oops, let's go back one. Negative correlation will look like a negative slope as you go from left to right. This could be the more miles I drive and the level of gas left in my gas tank. And then we also have no correlation. I like to think of it like the stars in the sky. You could connect the dots. There's no rhyme or reason to the pattern or the relationship. It could be comparing the temperature outside and the color of your shoes. Something that's just completely random. So the first example we're going to look at is looking at the correlation. So technology says that the graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there's a positive or negative correlation, describe its meaning in the situation. So before we start doing that, let's take a peek at the actual graph. Along our x-axis, we have the year. Looks like 2000, 2004, 2008. And as we go up the y-axis, it's students per computer. So computer sharing in their school. So as the year goes on, here in 2000, it looked as though there's maybe around 37 students per computer. If we get down here to what would be 2010, it looks like it's maybe 9 students per computer. So what kind of correlation would this show? So we look at the trend from left to right and what this would look like. So a sample answer for this would be the graph shows negative correlation. Each year more computers are in Maria's school, making the student per computer rate smaller. Okay. Next example shows mail order prescriptions. So graph shows the number of mail ordered prescriptions. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there is a positive one, let's describe it as well. So looking at this in 1995, we can see there's roughly maybe 87. In 96, we're up to almost 100, almost 110 in 97, and the trend continues. So we can see that there is definitely a positive correlation. So we can get rid of this, and actually this one too, because as we see with each year, the number of mail order prescriptions has increased. Okay. Oops, excuse me. Let's get back into the PowerPoint here. All right, we'll flip through. We know it's A. All right, next example. All right, line of fit. So it's a trend line. So now that you have identified that correlation, you can then look at the line or a line that all the data points lie close to. It follows the trend. Now, it will not touch every single point necessarily. We're not saying that every trend is linear, but they show a positive correlation. Your goal is to draw a line that goes through as many data points as possible following the trend, or at least cuts it in half. And steps for doing a line of fit. So you'll make your scatter plot and determine where any relationships in the data exist. Whether this is where you look at that correlation. Is it positive, is it negative, or does it look like the starry sky and there's nothing that you can see as a trend? Next step, you'll draw a line that seems to pass close to most of the data points. If you can get it to go through some data points, that's great. If you can't, get them as close to possible, and we can find reference points on the coordinate plane. Third step is you're going to use 2 points on the line of fit to write an equation. You guys have done this. Pick 2 ordered pairs. Find your slope. Plug it into point-slope form with one of the points, and simplify. Last but not least, with a line of fit, we can use it to make predictions about the future or other values that the graph may not show. Okay. So the table shows the growth of world population. Identify our independent and dependent variables. We want to make a scatter plot and determine what relationship, if any, exists in the data. So let's just take a peek at this table. We have the year. This is going to be your X value or your independent value. Time is always independent. Our population is our Y or our dependent. In 1650, there were 500 million, 1850, 1,000 or 1 billion, and so on and so forth. Okay, these are in millions. So let's look at step 1, creating a scatter plot. So we'll make the scatter plot. Like we said, our independent variable is the year and dependent is the population in millions. And as the year increases, and as we make the scatter plot, we can see, and even from the table we were able to see as the year increases, the population increases. And there's a positive correlation between those two variables. Now looking at this takes slowly starts to grow and then goes up very, very quickly. So when we create this line, we're going to have a very steep slope going through our data. Now, the step 2 is to draw a line of fit in the data. Now, one line will pass through all of the data points, so we'll draw one that passes close to the points. Here is an example of a line of fit. Okay, it follows that trend. It goes very quickly without leaving out what's over here that we started with. So we started slowly and then got very quick. So this is a sample. Will yours and your neighbors be exactly the same? Not necessarily, but they will be close, and therefore you should have slopes that are similar but not necessarily the same. It depends on the points and the area that you drew your graph through. The next part is to write the slope-intercept form of an equation. So we can pick the 2 points that this passes through. It happens to pass through 1850, 1000, and 2004, 6400. And those were based off of also on our table, so we were able to identify exactly which those were without having to estimate on our graph there. So we will use those 2 points to draw that line of fit. First thing, find your slope using your slope formula. We're going to let x1, y1 be the 1850, 1000, and x2, y2 be 2004, 6400. If you do it the other way, it'll still give you the same answer. And with a slope then of 5400 over 154. All right. So we're going to use our slope in either point slope form or the slope intercept form to write an equation of the line. Like I stated yesterday, I'm going to go with the point slope form of the line. I'm going to choose the point 1850, 1000 and our slope 5400 over 154 and plug it into point slope. We're going to distribute. And at this point, I can estimate kind of what my slope is, 35.1, and then finish off. Y is approximately, our equation would be y equals 35.1x minus 63,870. These are large numbers because the quantities on our graph are also very large. All right, moving on to the next example. Here we have a table that shows the number of bachelor's degrees received since 1988. We want to draw a scatter plot and determine what relationships exist, if any. Remembering years are always going to be on your x-axis, and then the degrees received would be your y-axis or independent. If need be, because of our values, we can use a number break on our vertical axis. So here's an example scatter plot and the answer already. We can see as we plot these, we used a break here to get to 1,000, went up by 25s. We can see year 2 is about what, maybe 1051, 1052, or 1051, right there it is. 4, 1136, and so on and so forth. So as we can see that there is a positive correlation between the values. As the years increase since 1988, the number of bachelor degrees received has also increased. Looking at this set of data, we can draw the same set of data. We can draw a line of best fit for the scatter plot. So looking at our set of data, this is the same one we just drew on the previous page. What line of data would fit the best? When we're looking at it, we want to make sure that it is indeed linear. So I can get rid of D because we're not going to play connect the dots as we go. We want one continuous line. These three do have a continuous line. I'm going to get rid of C here because that is showing zero change over time. Okay, a slope of 0 would show no change at all every year. It stays the same, which we know that to not be true. And A I can eliminate because it is showing a negative slope. So your answer would be B, would be your line of fit. We can also see that it went through 2 of our points on the graph, which if we looked at our table happened to be 4, 1136, and this point here, which is 10, 1184. Those 2 points, and knowing that that's where our line is, come in handy when we go ahead and write our line of fit, which we will do now. So now we want to write in slope-intercept form an equation for the line of fit. Since we were able to identify from the graph and the table that we had what our points were, we can go ahead and do this in an appropriate manner. So first things first, we need to find our slope. So I'm going to use this as x1, y1, x2, y2. So m equals 1,184 minus 1,136 over 10 minus 4. Okay, so 1184 minus 1136 is 48 over 6. So your slope is a positive 8. Then we can choose one of the points. I'm going to choose to use 10, 1184 and to write our formula in point slope form. Okay, so y minus 1184 equals 8 times x minus 10. First step is to distribute. So y minus 1184 equals 8x minus 80. Add 1184. So y equals 8x plus 1104. And that is it. So your answer is D. All right. Moving on to linear interpolation. So linear interpolation is used to predict values inside of range of data. So using that line of fit that you wrote, the equation for the line of fit, to make predictions. So first example, the table here and the graph show that the growth of the world population over time. Okay, we looked at this already. We went through and we wrote this equation earlier in the lesson. Now what we want to do is use it to predict the world's population in 2025. Okay, so what we will do Then we're going to evaluate our function then and let x equal 2025. Using our equation of best fit line, we are going to substitute our value 2025 in for x. So 31.1 times 2025 minus 63,870. You get approximately 71,077 and a half minus 63,870. And by subtracting, we are looking at 7,207.5 million people in 2025 in the world is our prediction. Since we're not to 2025, we can't know if that is true, but we could predict 2020 or 2019 and see where we are with that to see was this line actually accurate. Okay. Now let's look back at bachelor's degrees received. We wrote this equation using your points 4, 11, 36, and 10, 11, 84. Okay, so with that, when we did that, we got the equation y equals 8x plus 1104, where x is the year since 1988 and y is the number of bachelor's degrees in thousands. So to predict the number of bachelor degrees that will be received in 2015. So we need to figure out what year is 2015 since x is the years since 1988. So we know that 1988 is year 0. So we need to know 2015 is then year what? The way to do that would be then to take 2015 minus 88, so that's actually year 27. So using your equation, y equals 8x plus 1104, you're going to substitute 27 in for x. So 8 times 27 equals 11, plus 1104, we get 1320 plus 1104. All right, and remember this is going to be in thousands. So we get y equals not 1320 plus 1104. We get 8 times 27 is 216 plus 1104, and 1104 plus 216 is 1320. So our answer is 1320,000. So what we want to do is, which answer would that then correspond to? It would be A. You would take your 1,320 times 1,000 to give you 1,320,000. Okay. All right. The last thing we're going to talk about is correlation and causation. Correlation, like we talked about, is the data that shows a relationship between two variables. Okay. So if a data is an example of shows correlation, it's going to show a relationship between them, whether it be negative, a positive relationship, or whatnot. Causation is really is about what it sounds like, causing. The change in one variable causes a change in another variable. Okay, so they fully rely on each other. More than it's not just a relationship, but one causes the change in the other. So let's look at some examples. So Shauna measured the height of a sunflower plant after the seed was planted. Okay, so measurement 1 through 7 shows days since planting is 0, and then every 10 days after planting, she measured the height. So 0, 0, 3, 11 inches, 19 inches, 26, 32. So part A says graph the ordered pairs as a scatter plot, days since planting and height. So your days since planting is going to be your x, your height is your y. So just this one here, we only need the first quadrant because we're not worried about any negative negative values, no heights or day negative. Label your x-axis days, your y-axis height, and graph your ordered pairs, and you'll get something that looks like this. Okay, So we want to know, does this show any sort of correlation? Well, as we can see, for the first 10 days, there's no growth. But then once we hit day 20 and 30, 40, 50, 60, and so on, we are seeing growth. So we would say that, okay, do these show a pattern? Yes, they do. If you drew a line through the center of these points, would your slope be positive or negative? Well, they would be positive as we see them going up. So this would show correlation. It would show a positive correlation, because as our x values are increasing, so are our y values. So as the number of days increases, so does the height. And that would be your explanation. This is positive correlation because as the days increase, so does the height of the plant. Okay, I'm just going to flip through a couple slides here that kind of show those same things that we just talked through. Okay. As x increases, so do y. So positive with the number of days increasing, so does the height. The next part is to look at this, is determine whether this shows causation. So when you do this, you have to ask yourself, does the number of days since planting cause the plant to grow? Yes, that's what happens. Plants grow over time. So the farther away from planting you get, you should start getting more recordable heights with the plant. Okay? So let's look at causation specifically. Correlation does not prove causation. If two variables show causation, then a change in one variable directly causes a change in the other. On day 0, I plant the plant, there is no height. But the longer the plant is given, the taller it's going to get. One causes the other. Time allows that plant to grow. So looking at these next examples, let's determine whether each situation illustrates correlation or causation. So Rebecca records the pounds of each type of vegetable in her garden. Each type of vegetable in her garden produces each year. She discovers a negative correlation between the pounds of sweet potatoes and the pounds of spinach it produces. Okay? This is correlation because the sweet potato growth is not causing or affecting the spinach growth. Okay, so if we look at the relationship of sweet potatoes to spinach and we make a scatter plot, it's going to be correlation. We can see a negative trend, but one is not affecting the other directly. Okay, my sweet potatoes can't determine how much spinach I'm going to get out of my garden. Let's look at B. A local police department report states that there's a positive correlation between the number of days it snows and the number of car accidents annually. Well, we live in Minnesota. We know what this is like. The more and more snow we get, the worse the driving conditions can be, and therefore more car accidents. So this would be an example of causation because weather can be a contributing factor to those accidents. Okay. Two more. Let's look at C. So when mixing orange juice from concentrate, there's a negative correlation between the amount of water added and the concentration of the orange juice. Well, mixing orange juice from concentrate, you usually add in the mix, and then you add certain amounts of water. The more water you add, the less concentration that the orange juice holds. You might think it tastes watery, things like that. This would be causation. You add too much water, you're going to get watery orange juice. You don't add enough, it's going to be very bitter to drink. So yes, it is causation. The water does cause the concentration that your orange juice has in the end. And D. Teresa sells crafts at a local flea market each week. She notices a positive correlation between the number of necklaces and the number of puppets she sells. So we have to think to ourselves, does the number of necklaces she sells affect the number of puppets she sells each day? Does one affect the other, or is it just the trend of that market each week? Well, this is correlation because necklaces sold don't cause puppets to be sold. Okay, just because someone buys a necklace doesn't mean they buy a puppet, and vice versa. All right, that is the end of the lesson. The notes and the video will also be posted on Schoology for your reference as well. Your assignment will be the 4445 packet due tomorrow.